Okay, so welcome to lecture 3. Today we will be talking about relationships and SQL. So, first of all, we will go through relationships and junction tables, which will tie into last week's lab, and then we will talk a little bit about SQL and basic commands. So, first of all, making friends with relations. We've seen this already. Relationships link data from individual tables to increase the usefulness of a database. So a company's information may contain many tables of related information. And when the information between tables is linked, it is called a relationship. So the keys to the relationship. A primary key unlocks the relationship potential of a table by creating a unique link between tables. So the related field between the two tables must be of the same data type and size. So here, the employees table, you have your employee ID, which also appears in the orders table. And you can see a join line representing the relationship between the tables graphically. We talked a little bit about primary keys and foreign keys last week. When tables relate, the primary key of one table becomes a foreign key of the other table. So, for example, here in this employee table, employee ID appears in the employee table as a primary key, but in the orders table, it is a foreign key. And referential integrity protects related data that is stored in multiple databases, or in multiple tables rather. So it will prevent a customer in a customer table from being deleted if the customer's ID also appears in the order table. So this is what a relationship looks like. So here are two tables, um, students and participation, and there is a relationship established since we have the primary key of one table appearing in another. So one record in the student table is related to one record in the participation table. So to set up a relationship, we can add one table's primary key to a like field with the same properties in another table. In order to determine which table's primary key to use, you must first determine the type of the relationship. So there are three types which we saw briefly last week as well. The one-to-one relationship, the only one matching record between two tables, and this is not very efficient, and we will see why. We have the one-to-many, which is the most common type of relationship. So one record in table A links to multiple records in table B. So, for example, if you have a list of suppliers for the music store contained in one table A, it is linked by the supplier ID to table B, which contains all of the products. So if you search table B, which contains all different kinds of products, we can also see who supplied those products, and that which we can find in table A, which contains the list of suppliers. And then we have many-to-many records. So multiple records in table A are linked to multiple records in table B. So for example, we have a music store database. Table A contains customer information. B contains CD inventory. A record for Bob from table A may be linked to several records of CDs in table B by linking the customer ID field. So if B contains the CD inventory, Then the record for a particular CD can be linked to several customers in table A. And we will see this more clearly in this example. So here, there are showing two ways of drawing this, the closed foot model and the chain model. Student and class, these two entities, they have a many-to-many relationship. The chain model will say it's an M-to-N relationship between students and class. So M students can have many classes. So for example, Bowser can be taking these three classes, and the same with Smithson as well, can also be taking these three classes. So there's a many-to-many relationship there. Um, this cannot be implemented as shown next, but just for illustrative purposes. Let's have the table name with student and the table name with class. So the student table and the class table. This table has many redundancies because we have, for each student, we add a class code. So Bowser shows up here because he's taking the first class, shows up here because he's taking the second class, shows up here because he's taking the third class, and this has a lot of redundancies. So what we can do is change the many to many relationship into two one to many relationships. So we go from many students can have many classes to one student registers and shows up in a class. And we can see this here. So now we have the student table over here, which just contains the students' IDs and names. We have the class table here, which contains just the classes that exist. And then in here is a what they call a junction table. So this junction table will use a combination of the foreign keys, the combination of student name, or student number rather, and class code to create a more efficient relationship. So here, um, this intermediate table is called the junction table, and it is used with many-to-many relationships to join primary key fields of multiple tables. So, for example, in a music store database, the primary key fields of orders, musicians, inventory, and prices table are all contained in a separate table, which acts as a hub for the tables of the database. And we'll see this clearly from last week's lab. So from last week's lab, we had some data from a shop where they had the customer entities. They had products and they had orders. So this was the first thing you were supposed to do in the lab, the conceptual ER diagram. So we have customers with name and country. Here, name is the primary key, but that's not always a good idea because names can be the same, but it's application dependent. Um, but a customer has name and country attributes. The product has name and category attributes, and here we set name as the primary key. And then the order, which has order ID, day, month, year, has an end-to-end relationship with product. So an order contains product, n orders can contain m product, and this has relationship has the attributes order quantity, unit price, and total price. So this was an example of the schema you were supposed to do. Some of you did, some of you did not. So for customer, we have customer name, sorry, rather, customer name and country. Data type will be varchar, strings, basically. Um, cannot be null, and we set name as primary key. For the order table, we have order ID, total price, customer name. Um, we set the order ID as the primary key and the customer name as the foreign key. The customer has an order. And here, the price total, the data type is set to decimal, to two decimal places. And I will show you a link to the MySQL documentation where you can find out more about data type and what they mean. And then here, product as well. So product has a name, which we set as primary key. And then there's the category attribute of the product table. And this is the junction table. So what is good about MySQL is that this junction table here can be automatically added for you. So this is the logical ER diagram that you were supposed to do, or supposed to make, where we have the customer table, the product table, the order table, and then the junction table called order line. So I'll just show you quickly how this sort of junction table can be added automatically in MySQL Workbench. Okay. So here I have got customer, I've got orders, I've got product. Between orders and product, there's an end-to-end relationship. So if I click on place a new end-to-end relationship, I can click on the orders table and then on the product table, and this has been created automatically. The order has product, so it shows the different keys, the different foreign keys in there. So from product, it has product name. From orders, it has order ID and orders customer name. And you can add more columns as well if you like. So that this has converted. If you can see, we started with a many-to-many relationship, and when it added this table automatically, it converted that to two one-to-many relationship. Okay. So, and um, we'll see more of this in the lab as we go along. So, moving on now to SQL design and implementation. The SQL stands for Structured Query Language, and it is the most commonly used relational database language today. And it works with a variety of different first generation programming languages, Visual Basic, Python, Java, and so on. And it is used for data manipulation, data definition, data administration, and all these functions can be expressed using an SQL statement or command. So the requirement, it must be embedded in a programming language or used with a 4GL like Visual Basic. As your project, some of you will probably go through Python um, to use SQL. Um, it is also a free-form language, so there's no limit to the number of words per line. There's no fixed line break. And important, you have your syntax statement. Words and phrases are always in lower cases. Keywords are in uppercase. But not all versions are case sensitive, but certain versions are you have to have keywords in uppercase or you'll get an error. Depending on what version you use, you'll get used to it. So SQL is a relational database, and a fully relational database management system must have the following characteristics. So all info is represented as tables, which we've seen already. We keep the logical representation of data independent from its physical storage characteristics. The physical storage would be when it's specifying how many number of bytes to use. So when you type in bar chars, comma 45, um, or decimal 5, comma 2, that is the physical storage characteristic. Um, it must use one high level language for structuring, querying, and changing info in the database. It supports the main relational operations. It supports alternative way of looking at data in tables, so which you will also come to hear of this as views. So you can create several views from the same database. Um, it provides a method for differentiating between unknown values and nulls. So we can strictly specify if a value in a table is unknown or if it is null. And it supports mechanisms for integrity, authorization, transaction, and recovery. So in terms of design, SQL presents all information in the form of tables. We'll be working with tables, and it supports three relational operations: the selection, projection, and join. And these can be used to specify exactly what data you want to display or use. And we will see more about um, projection and joining in the coming weeks. And it can be used, the SQL language, for data manipulation, data definition, database administration. So here's table design now. So a column will describe one characteristic of the entity. The row will describe the occurrence of an entity. So an entity is, let's say, employee, for example. The employee has attributes name and address, which the columns describe. And you have three employees in here. So the three occurrences of the employee entity in the rows. The main keyword for retrieving data from the database is the select keyword. And you will fetch information, display information a lot of times using select. So the keyword select star asks for all columns, and you select something from a table. So we're selecting all columns from the publisher's table, and that will give us all the columns: publisher ID, publisher name, publisher address, and publisher state. And you can make your queries even more specific. So here, we're selecting all columns from the publisher's table where the column state is California. So now we only show publishers in California. And we can use the keyword insert to put data in the table. And we use insert into the table we want to insert into publishers, and then the specific values in parentheses. So here we're going to add a new row into this publishers table. The ID, publisher ID, new publisher ID would be 0010. Publisher name, Pragmatic. The publisher address, 4 Fourth Lane, and the publisher state, Illinois. And that has been added here. So the table has been updated right here. And the, the number of values in the parentheses should match the number of columns that already exist in the table. Okay. So there are two types of tables which make up your relational database. They are the user tables, which we will spend most of our time on. And this contains all the information that is in the database management system. And then there's the system tables, which the DBMS keeps by itself, and it contains the database description. So to use SQL, we can we can go via um, different programming languages, Visual Basic, MS Access, Python. We can go via the MySQL IDE. We can also go via the command prompt of MySQL. So there are different ways to do this, depending on what you want to do. It allows for a lot of flexibility. So to begin to use SQL, we have to first of all create a database, and that's done using the create database statement. So we create using this keyword, and we type in our database name. And then depending on the version we are using, we may have to specify to use the database. One thing good about using MySQL Workbench is that we can, after defining those tables with with the logic with the EER diagram, we can forward engineer, and that will create it will populate it will create a database for us with all these create statements added already. Create database, create table, and so on. So that's one advantage of using Workbench, and we'll see this in the coming labs. To create a table, we can use the create table keyword. So we create a table, we give it a name authors, um, and then we have the column author ID, and we specify the data type as an integer, 9 digits long, and we also specify that it cannot be null. So that so that's the first um, column, which we designated this as the first column by the comma. The second column would be author name, 40 characters long, 40 character strings, and this can also not be not null. So we've created a two-column table and specified the data type. To insert into the table, we use the keyword insert into. So we insert into the table the values, um, author ID and author name. And then we can start selecting from all columns from our authors table. We can also select specific columns and specific rows. So if we only want to display the author's name and city from the following table, we can select author name, author city from publishers table. So this is selected, this is selected, and this is what we will end up seeing. To delete data from the table, we can use this delete statement. So we can delete from authors where author name equals John Smith, and that will delete all rows where the author name is John Smith. So we have to be careful um, with the delete statement. We can also update information in the database using the update keyword. So we can update the authors table, and we can set all the author's names to hello because we have not specified which row exactly. If we wanted to specify which row, we could have said update authors, set author name equals hello, where author ID equals 00000001. But here we haven't specified. So all rows in the author name column have been set to hello. Change the table in the database. We can alter table and then we can add a characteristic. So here we're going to alter the table authors and we're going to add a new column called birth date. The date type, the data type here is date time, which is a specific data type for storing dates and times. And we can say it can have null values in there. And when we run this query, we end up adding a new column to the table called birth date. And then we can populate the column as we like. To delete a column or row, we can use the keyword drop. Again, alter table, authors, drop birth date, and we can drop this column already. And this is also a very powerful keyword, and you have to be careful how you use it because you can lose a lot of data by just um, carelessly using the drop keyword. You can also drop the entire database um, just by using drop. So drop database authors, and your database will be removed, and the memory will be returned to the system. So this is very powerful, and it should be we should be careful how we use this. So just to conclude, SQL is a versatile language that integrates with numerous fourth generation languages and applications. It simplifies data manipulation by reducing the amount of code required. We've used very simple commands to do powerful things, and it's more reliable than creating a database using files with linked list implementations because this um, structured query languages have measures in place for verifying the integrity of a database. So you are it's less likely that something goes wrong with your database. You have a more reliable database using SQL. So in summary, we have talked about uh, relationship conjunction tables, and the main thing about junction tables, which we can see from last week's lab, is that it converts one many-to-many relationship to two one-to-many relationships. And we also saw a quick overview of SQL. So that is it. What we could also do is read this chapter. This is available on Moodle, and it clearly explains um, database design for a fictional company. So go through chapter 11, a database design case study, and have a read through. I have also put here links to the documentation. So um, the main MySQL documentation is here, which um, has a lot of information that you might need. So installing, upgrading, downgrading, quick tutorial if you're interested, and data types. So if you want to learn more about these different data types, so if you want to learn more about varchar, what varchar means, you want to learn more about the date time data type, um, integers, um, decimals, numerics, and so on, you can go here. And you can also have a look at different functions and operators that exist. So that's the main documentation. I also included um, this W3 Schools link where they have a lot of quick tutorials on the different commands of SQL. So if we go back to the website, this gives you a quick introduction. If you are not sure what um, uncertainty does, you can quickly look here and it quickly gives you an overview of what uncertainty does. You can see an example, um, and you can sometimes run the example as well. So these two links are very helpful. And if you need more, there are some short exercises slash tutorials on Khan Academy as well. So thank you.